Welcome back, Calcsters. Today, and this should have been the bell ringer, this is going to be next year's bell ringer, but we're going to sneak it in here. Before we get going, we are still, just so you guys are aware, we're still in chapter 4.3, and we're just going to build some intuition to start. So, we're going to be looking at using derivatives. And obviously, it's like our whole focus right now. It's literally the entire chapter is applications of the derivative. But we're going to say using f prime. And we'll build up to actually doing this. But let's look at an Algebra 2 version of the same question, and then we'll introduce the calculus version of it. So on one example, I just want you to sketch the function that does the following. So let's say we sketch, and we'll just call it f, and we're not going to use a derivative at all in this one example. So here we go. I'm going to give you a bunch of information about this function f. I'm told that f of x decreases for all x in, and I'm going to give us a couple different intervals. Let's say it's -2 to 1, union, or and, if you would rather. Let's say it's also decreasing from 3 to infinity. So I know when my function is going downward. Okay? More than that, we'll say f of x has roots at, we'll say x equals -2 and 3. And I know that f of x, this last little part, is increasing. And let's see, we're increasing for all x in the interval -infinity to -2, union 1 to 3. Now, I can give us more information than this if we wanted, but I want you guys to just, from here, let's just sketch this. And we're going to be doing bigger problems once we get to actually use calculus, but this is a good intro. I'm going to give you guys a second. Really roughly, I want you to sketch that function that I've described. And we should all have a similar-ish picture. So I'll give you a moment. Do you remember doing problems like this in Algebra 2? It's been a couple years. I heard a comment, but I didn't catch what it was. Okay. Was it you? Okay. I thought you said, can you give us more time? But if not, sweet. Okay. If I want to put this thing on here, where would you guys start, just out of curiosity? The roots. So I should have gone, so here's -2. I'm going to put the roots on. So here's -2 as a root, and 3 as a root. And it's right there. Now don't misread my scale. I have the ticks on my page is what I'm doing. Okay, so there's my roots. Now from here, if we just want to be able to sketch it, it's not going to be perfect, but we have at least a pretty good feel for it once we start drawing it. How do I draw that it's decreasing from -2 to 1? What does that mean? So I'm going to go start at -2. Which direction should my function go if it's decreasing? Down. And it's going to switch to being increasing at 1, right? So let's see. I need to go down, and I need to be able to switch to increasing once I get to 1. Right now, was I going downward the whole time in here? Okay, and then if it switches to increasing when x equals 1, and I'm just guessing where this is, just so you know. I don't know how fast it went down. But if I curve back up, am I now increasing from 1 to 3? And then what's my function do past 1? Or past 3, I'm sorry. It decreases. Does this function have a root there and do exactly what it just told me? Okay. The only other part that I'm worried about, I increase here. I'm cool with that. I also increase from -infinity to -2, which here's -2. I'm going to have to fix my graph a little bit because if it's supposed to be differentiable, it's going to have a cusp here if I do what I need to. So I'm just going to switch to green just so I can make better sense of it. I know that it decreases on both these intervals. I already have it. It increases from -infinity to -2. So maybe it does something like this. I don't know how it's increasing. But then it turns here, still decreases, and then we just replace that little orange section that I just drew with the green instead. We just replaced that one little spot that needed fixed. Do you guys agree that this is kind of a nice graph? Like, it's not super detailed, but it's enough to sketch the function, right? Now, we just used all calculus right here. We didn't ever once mention the calculus, but if I want to find when a function is decreasing, it just means it's when a derivative is negative. If I want to know when a function is increasing, it just means the derivative is positive. And if we can find where these things change, then we can get all this information for any graph that we ever give. So that is where we're jumping in today. Before we start doing some calculus, questions regarding any of that? Okay, now, you guys, especially if you had my pre-calc class last year, you're going to recognize some of the notation stuff that I use, and I think we might have used a little bit of it this year, but let's get graphing. So using f prime, our real focus today is how do we actually use this, and it turns out that we can use this to find intervals of increase and decrease. Now, there's there is a better way to word this where it makes sense grammatically. But are you guys okay with saying this means find the intervals where the function f of x is increasing and where it's decreasing without having to write the extra 10 words? Cool. So here's our goal. We just need to do this. Now, it turns out it's super easy to summarize these rules, and you guys have actually already summarized it. A function decreases when f prime is negative, and it increases where it's positive. We just need to summarize that. Now, we're going to make it a little bit more rigorous than just some bland statement. So we just have to make sure that we are all on the same page. We're going to let f of x be differentiable. And I'm going to shorthand differentiable with diff apostrophe BLE. That's a lazy contraction. F of x is differentiable on the open interval from A to B. Okay. Now, one of the weird things that if you are really into the theoretical side of all this and where we start going into like talking about continuity and things, if a function is differentiable, it must have been continuous. Like there's no other way around it. You need continuity for differentiability. So the second I tell you it's differentiable, you're allowed to assume, and more than that, it implies that the function must have also been what? It was continuous, and I'm just telling you it's continuous and differentiable, but we only have to say this because it brings in the other stuff for free. Okay, here it is. We're going to say that if, and there's two statements here, if f prime of x is greater than 0, then f of x is doing what? Increasing. Easy. And on the other side, if f prime of x is less than 0, then f of x is doing something different. Decreasing. Okay. I'm going to give you all a second because I want to make sure we get this. Be really careful. You need f prime and all that stuff. Now, we're not really going to put all the pieces together to graph today. I think that's our focus for the next section, which coincidentally is going to be our last section of chapter 4 before the break. Because we're going to split it into two halves. Okay. Everybody have this written down. First and foremost, there is a 100% chance this is going to show up on the AP test. I guarantee it. It will show up. On which intervals does f of x increase or decrease? You'll probably see multiple questions with that. Like, it will happen. Realistically, almost everything that we do will show up on the AP test because I pretty much teach to the AP test. Cool. This will show up. Now, we're going to bring in some old ideas that will kind of help us here. I'm going to make a comment. I'm going to see who can help me remember this. I'm going to make a note underneath. Notes rather. If f prime of x is equal to 0, and I'm going to switch these colors, equals 0 or undefined, we may, and I'm going to underline that, we may have what? If I find where the derivative is 0 or it's undefined, we might have a something. And this is what we talked about last week. Think about it. Hit it. An extrema or an extrema, right? Because if you think about a curve, here's a maximum or a local max, the derivative is 0. Okay, nothing crazy there. We may have extrema. Not guaranteed, right? We have to check, but we might. So there's our first statement. Where this happens, and I'm just going to put this one in yellow here, this has a name. What do we call the points that we find, the x values for which f prime is 0 or undefined? These are my critical numbers. Now I'm going to call it critical values, but whether you call them numbers or values is both fine with me. Okay, this is what we were finding last week, finding the critical values. Okay, beyond that, just some nice things to remember. And I'm going to switch color for this one. I want somebody to help me remember what this word means. Multiplicity. Do you guys recognize the word? What does it mean? Or how do we use it? If a root or factor shows up the certain number of times, right? So whoever's phone that is, if it keeps going, I'm going to make you come turn it down, but for now, it's fine. If you give me, given f prime, or it doesn't matter, we'll just say f of x. It could be f prime or f double prime. It doesn't really matter. Give me a function. Given f of x, the number of times a root shows up, and it could be factor because we can move between roots and factors pretty easily. If you give me a function, the number of times a root shows up tells behavior at that root. Now, the behavior that we're looking at. Abigail, nice job remembering this. Do you remember this step further? If it's odd, if it shows up an odd number of times, so whether it's f prime, like if it's my critical number, awesome. If it's a regular function, also awesome. We're going to say if odd, and I'm going to say if odd number of times, because everybody gets this goofed up where you want to just look at the number and see if it's even or odd. It's how many times it shows up. We cross, and I'm going to make this implies. If it's odd number of times, we cross x-axis, which is a really wordy way to say we change the sign of the function. What's the alternative, Fern? If even, number of times, then my graph, touch and turn. Touch, x-axis, and turn. Now, we're going to use these to our advantage. And if you don't do it, it's not the end of the world. All this is going to do is save massive amounts of time. So it's up to you. Like, you can get by without it, but it is worth having. Okay. We're going to put these two pieces together, and you will likely have some time for homework. The second half of the section is super quick and easy. If there's questions, I want you to ask them while we're doing a problem. Cool. So we have two problems to do. Right meow. First one is I want us, and it's really hard for me to not put all these pieces together, but that's our next section, I'm pretty sure. I'm going to verify that. Okay, not very many times that I do stuff differently than your book, but I'm going to present it differently than your book. And we'll look at what the book does. I think my way is nicer, but if you want to use the book's way, we'll look through that as well. So here we go. Examples. I want you to help me identify, and I'm just going to call that ID, where, and this is going to be like which intervals is what where is going to mean. F is increasing, decreasing, and, if possible, extrema. And we're going to point a little bit ahead of this. Now, we'll see the extrema question more. My main focus here, just so you all are aware, I care most at this point in time about increasing and decreasing, but it's a really natural place to tie it in with extrema. Okay, let's look at a function, and then we'll dig into the graph. And it's going to be nice if we pick a graph that nobody understands what it looks like. So let's do that. For our first one, just so you can't cheat by thinking about it in your head, not that that's really cheating, I want us to think about the graph of f of x equals e to the x times x squared. Now, we all have this picture in our head, right? Not even a factors, the way I've written it, I didn't have parentheses, so it's hard to tell. But e to some power is never going to be 0. I can get close to 0, but it'll never be 0. What value of x makes x squared 0? 0. Now, coincidentally, just to make sure we can tie it to the multiplicity, how many times does x show up as a factor? 2, which means I'm expecting my graph to cross the x-axis there if we were to graph it, because it's a touch and turn. My bad, not cross. It'll touch and turn around because it shows up an even number of times. Okay, that's all right. We're not actually graphing this thing right now. All we're looking for is where f is increasing or decreasing. Okay, right off the bat, if I want to know where either of these things is happening, do I work with f? What tells me if a function's increasing or decreasing? Like, I could check a bunch of slopes if I wanted to, but maybe there's a better way. I'm going to call this step 1. What do we need to do? Yeah, let's find f prime. Okay. Which rule? I'm going to let you guys quietly think about it for about 5 seconds and then quietly chat with your neighbors for 5 seconds. I'm going to call on one of you random people to help me. How do we find f prime is a question that somebody's going to answer for. All right, number 6. Who dat? Okay, Fern wants to use a product rule. Good news and bad news. Good news, that seems doable. Bad news is I don't remember how to do it. Number 9. Look it up. I don't remember. I have no idea who number 9 is. I heard a noise. Okay. First. So let's pause there. Let's do that one first. What's the first function here? E to the x. And I'm going to leave some awkward gap here because I want to make it look nicer as I'm doing it. Don't know why that just turned off. Weird. What's the derivative of the second? Do you guys agree it feels more natural to write it here? If you want to write e to the x times 2x, I have no issue with it. But this is, in my mind, more natural. This was first times the derivative of the second plus, number Kalisha, what am I going to add to this? Good. So here's the second, x squared. And a bigger question, I'm going to stick with you, Kalisha. What's the derivative of e to the x? It read a book once. There's a stupid meme comic about it. I want you to think it every time. When it seems like such a weird thing to say. Do you remember the stupid comic that I showed about the numbers? They read them. Okay. He read a book called The Derivative. Everybody else, what did it do to him? It didn't change him. He was unchanged. E to the x. It's just itself. I cannot think of it without thinking of the silly comic. So I'll re-show you the comic if we need. Okay, we have the derivative right here, right? Okay, step 1, find critical, or blah, 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 dang it. Find f prime. What's step 2? Let's find critical values. Okay, and I get crit val by doing what? What's it? The derivative. So you guys are going to help me do this real quick. I'm going to set the derivative, f prime of x, equal to 0. And we're going to have to start looking at some bigger factoring stuff, because I don't want you to have to take out your calculators. I think we can all do it, but we're about to find out, at least initially. If I'm trying to solve this and we're factoring, always the first step is what? GCF. What goes into both, for sure? So x and an e to the x. Are we cool if we take out both of them? Okay, so this is x, e to the x, because they both have it. And what's it leave behind? 2. And Sean, do you agree with 2 plus x? Okay. Now, this is weird, and there's a couple ways we could write it. Can you tell me how many factors we have written right here? I think there's really 3, but there's only 2 meaningful ones. If we add a parentheses here, and you don't have to, and I never will, but if we add those parentheses, is it really clear that we have the 3 factors? All right, so checking it out. What value of x makes this first factor 0? Okay, so my critical numbers, and I'm finding them. Critical vowels. Crit. X equals 0 from this one. I agree. Okay. Isha, is there a value that makes e to the x 0? Even if it's negative like a billion, 1 over e to the billion is almost 0, but not quite. So not going to happen. Last one. Angel, what value of x makes this last factor 0? Negative 2. Now, here's all we have so far. Critical values. And again, we're not graphing the function, although we are right on the, we're so close to being able to do it. I am just resisting the urge. Okay, here's where I'm going to differ from your book. I like to organize these things differently than they do. I'm going to show you what they do, and it's not the exact problem, but I just want to make sure you can see it. They use these critical numbers to make a big table where they say, hey, look, here's the interval that we picked because they found the zeros just like we did, or the critical numbers, I'm sorry. They found the critical numbers, and then they split it into intervals here. Okay, they then check. What does this factor do? What does this factor do? So forth and so on. I don't do it that way. When I do these problems, and I think this is going to feel natural for most of you because you had my pre-calc class, instead of making a big ugly table and trying to work everything out, I'm going to make a number line. I really only care about the sign of these things, so I'm going to make a number line. Now, these number lines will get bigger and uglier as we go, just so you're aware, which eventually we might default to the table. But I'm going to make a number line where I'm only dealing with f prime of x. There's only 2 numbers that are going to go on this number line. 0 and negative 2, because these are my zeros of f prime. So I'm going to put them on the number line, and the only place that you can make a mistake doing this is if you have them in the wrong order. Which one goes first? Further left. Negative 2, and there's no thought to scale in my head. Negative 2 and 0. Okay. As I look at this number line, how many regions did we just cut the real numbers into? 3. I don't care which one you pick. I know which one I would pick. I need to check the value of f prime in one of them. Now, we could realistically check it in all 3, but we're going to use that multiplicity idea here in just a second. What's the easiest interval to pick a number out of, Makisha? Far left, middle, or far right? Easiest number to possibly plug into f prime. I would agree it's the far right. What number would you pick? 1. Now, you can pick 1, and I'm fine with that. If you want to be obnoxious to make sure that you don't have to think too hard, you could pick ridiculously large. I could pick 50 or 500 or 5 trillion. 1's a natural choice. Okay, really careful attention. Did I put another mark on my number line ever? No. I want you to be very careful about that. Now, here's my derivative. This is my derivative. Is this also my derivative, just in factored form? Okay, I'm going to rewrite this one just without the parentheses so it looks a little bit nicer. And it doesn't matter which one we plug into because they're the same. But I'm going to write this as 2, what? No, it's x e to the x, right? Okay, if I plug in a 1, let's just see what happens. And I'm going to plug into the factored form. We'll just say same here, or equivalent. Equiv. Because it doesn't matter which one I plug into. Is it more natural to plug into f prime of x here or f prime of x here in your guys' heads? The factored one? Good. I prefer the factored one as well. Okay, let's try it. If I plug in a 1 into this, I'm going to do more writing than I normally would. I get 1 times e to the 1 times 2 plus 1. Literally what I get, right? Now, I don't really care necessarily about the actual number. I care about the sign of it. That's all that I'm after right now. 1 times e, is that going to be a positive or a negative number? What about 2 plus 1? Positive. And what's a positive times a positive? Okay, so check this out. I'm going to write positive here and check for me very carefully that you have f prime labeled. Positive. Okay, now what does this mean my function is doing here? Increasing. And we'll look at adding maybe something else to this here in a minute. Okay, if I wanted to, and I don't, but if I wanted to pick something between here and here, Sean, give me a value in the middle interval. Negative 1. Do we really have to check it? No. No. Why? Why? when it's what is odd? It's multiplicity. What's multiplicity?
If it's an odd, it crosses the x-axis.
What do you mean it's odd? 0 is not even or odd. -1 is an odd number. I wouldn't use that. We're going to clean it up. Like I feel like I'm being aggressive, but it's intentional. How many times did this root show up? Is that one? Like that's my one, not the -1 that we could pick. Did this show up an odd number of times? So the fact that it showed up an odd number of times means my graph crosses the axis. And I know that that's what you're getting at, but the language is important. If it was positive and it crossed the axis, what must it be here? Negative. If you wanted to verify with -1, you can, and you will get the same thing. JJ, how many times did x equals -2 show up as a critical number or a root? Because it is a root here. Just once. And is one time, is that an odd number of times or an even number? And if it was odd, if it was negative and it crossed, what is it now? Positive. Okay. Now, as we look at these, if all I was asking is where is f increasing, where is it decreasing, can you guys tell me where that happens? Because another way to word this question is where is f prime positive and where is f prime negative? It's the same question, just worded differently. So, we're going to look at this. We're going to say for our answer, we have at least the first part. I think I can confidently claim where these things are happening, but I want you to be able to confidently claim them. We're going to put our answer here. F is ... and I'm just going to have two of them. Increasing is one of my answers, and we're going to write it. Anybody opposed to using our fancy shorthand? Do you guys use the shorthand when I use it? Like when I write for all, do you write the symbol or do you write the words for all? Okay, for all x somewhere, but it's also going to be decreasing for all x somewhere. I'm going to give you guys like 30 seconds. I'm just saying for all x in this interval. I want you guys to fill in the missing answers here. Where is f increasing? Where is it decreasing? Based on the information that we now have about f prime of x. For increasing, I would start at negative infinity. Yep, I'm increasing from negative infinity to somewhere. Okay, Rafa, give me one of the intervals for either of them. I don't care which one we start with.
For decreasing, it decreases from -2 to 0.
Okay, -2 to 0. Do I need brackets or parentheses and why? Parentheses. If a derivative is 0, it's definitely not increasing or decreasing, right? It's just neither of those. Okay, so everywhere between -2 and 0, my function is decreasing. Let's see here, number 12. Where is it increasing? One of the intervals. 0 to infinity? Okay, so I'm going to, interesting place to start, but that's okay. 0 to infinity. And interesting just because it's in a goofy order, but it really doesn't matter when we tie them together. Where else? Anybody can volunteer. Oh, sorry, go ahead. -2 to infinity would be everything here. Let's start further left. How far left do we start? Negative infinity. But I think that the idea is there. But if you don't write the negative, good. Okay, what goes between these, Leanne? Union. Awesome. Now, what's up? Okay. Have we answered the entire question? Have we? Okay, so check this out. This one, you will not be asked about the extrema on your homework. Just a heads up, I'm not going to give you homework today because we're not going to finish, and there's one more example that I want to do. So we'll get a chill night, but we're going to get a glance ahead at the next section. Okay, if I put, and I want you to do this as well, f here instead. So now on this, I have f prime and I have f. If f prime is positive, what is my function doing? Increasing. Do you agree that this means it's increasing? Okay, what's it doing here? Does this look like a graph that's decreasing? And over here, it's back to increasing. Now, I don't know whether it really looks like this because there's a bigger idea that we're dealing with about how does it curve. Because I could be going up like this. And don't change anything else, okay? If it's white, it's just for thinking right now. It could be increasing like this. You agree? Like a smile would. Could it also be increasing like a frown? And we don't know which one it is yet, but it's one of them, and that's okay. The fact that my function goes from going up to down, yeah, I don't have a good way to do it. Up to down, what did I obviously identify? There was an extrema. Is this extrema here going to be a min or a max? So we'll just make this comment. There is a max at, and we're not going to get ordered pairs yet, but at which x value? -2. And what's the other one? What's at x equals 0? A min at x equals 0. And all of a sudden, we realistically could probably graph this pretty well just with this info. Okay. You guys can pack up. If you didn't finish the homework over the weekend or you didn't have access to it, please work on it this evening. Tomorrow, we're going to do two things. We're going to start class with the derivative rules quiz, and then we're going to continue on by doing one more example like this, and then you have some time in class to work on the assignment. If we get started on the next section, that's awesome. If we don't, that's awesome. All right. Reminder, be quiet if you're walking by rooms that are map testing, and you guys have a wonderful day.